Learning outcome 36, first of all. Conservation of energy means that the total energy in a system remains constant, but it can convert between different types. So that's a kind of formal definition. I think it probably becomes a bit more obvious when we look at it in a worked example, which is our next learning outcome. So a stone of mass 2 kilograms rolls down a 3 metre hill. Calculate its velocity at the bottom. And conservation of energy then tells us that the total energy stays the same. So we need to identify really what energy did it start with, what energy does it end up with. So the energy change is gravitational changing to kinetic. Okay, so the information we were given in the question was that the height was 3 meters and the mass was 2 kilograms. And we're being asked the velocity at the bottom of the hill. So there's our standard problem solving technique. But we've also identified in the previous page the idea that the potential energy converts to kinetic energy. So we can write down at this point that the kinetic energy will be equal to any potential energy to work out that EK will equal EP. And that gives us a bit of a hint in terms of how we're going to solve the problem. So we're going to use the value of H and M given to work out EP. So G, remember, if you don't remember it, it's given in the data sheet at the start of the question, start of any exam anyway. So the potential energy is 58.8 joules. And then that becomes our kinetic energy in our half mv squared calculation. So 58.8 equals a half times 2 times v squared. Do the half times 2, so just simplify the bits that you can. So that's just v squared. A half times 2 is 1. So this one does simplify quite easily. And then if v squared is 58.8, then v is the square root of 58.8. Okay, so that's 7.67 ms minus 1 meters per second.